Hello everyone, my name is Pritham Kumar and I'm currently pursuing my BTech first year in Karnal Institute of Technology and Sciences. Today in this video I'm going to demonstrate my practicum number 8 which is direct memory access or DMA simulation using MATLAB. DMA is a technique that allows data transfer between an input device and memory without continuous CPU involvement. This improves system performance and allows multitasking. First program is about why industries prefer DMA instead of letting CPU handle all data transfers. In this program, I compare CPU versus DMA. We create an array called device data with values 10, 20, 30, 40, and 50. Using the for loop, the CPU copies data element by element, which is slower. In contrast, the DMA transfers all the data at once using a single assignment. At last, it displays all the information. We'll run it. CPU transfer output and DMA transfer output. This clearly shows that DMA is faster and more efficient. And second program is about DMA multitasking. Here's how I simulate the multitasking. The CPU is shown doing another task using a pause while DMA transfers data in the background. And this demonstrates how DMA allows the CPU to remain free in memory after DMA is 81, 90, 13, 91, 63. Third program is about what would happen if DMA was not used in a high-speed device like a hard disk. So we'll explain through a program. So it creates a memory with 5 locations. It represents 5 zeros. And device data generates 5 random numbers between 1 to 99. And using this for loop from 1 to 5, the CPU will transfer the data from one element at a time and pause for 0.5 seconds in each iteration and simulates how slow CPU processing. And it copies one element from the device data to the memory. I equals to 1, memory of 1 equals to device data of 1. Just so on, it will be transferring. Let's run and see. Memory after CPU transfer. And fourth program is about how DMA improves the system performance compared to CPU control data transfer. And this generates 1 lakh random values ranging from 1 to 99, represents a large data block. This starts a timer used to measure execution time and follow loop. The loop runs from 1 to 1 lakh. CPU processes each element individually. Memory of I equals to device data, it copies one element at a time. CPU underscore time equals to talk stops the timer, stores total time taken with the CPU. CPU time is 0.25 seconds, for example. DMA method is fast path. The timer starts, memory equals to device data, copies and data in one step, no loop, no iteration. DMA transfer stops the timer. See, we can see DMA time is so fast. Coming to the fifth program shows why DMA is important in real life systems like robotics or medical devices. Here we're creating a memory, creates 5 locations, initial 0. It generates 5 random numbers from 1 to 99. Using fast DMM transfer method, it copies all the 5 values into one step. If you run, so we can see real-time responses achieved. Program 6 explains how bypassing the CPU during data transfer saves time and power. So it generates 10,000 random numbers between 1 and 99. It presents a large block of input data and starts a timer and copies data into memory in one step. To see the DMA time. Plus, seventh program explains the role of DMA controller in efficient memory management. Here defines the function named DMA controller, takes input, that is data, returns the output, memory. This function acts like a DMA controller hardware. Creates a memory array of same size as input data. The memory equals to 0 line. If data has 5 values, memory has 5 slots. Memory of 1 is to length data is copies all data into memory in one step. DMA transfer controlled by DMA controller. You see that memory after DMA controller. Eighth program explains how frequent CPU involvement in data transfer might affect online gaming. For the loop runs 5 times, represents CPU operations, repeated CPU operations, and it pauses for 0.5 seconds each iteration. Since it shows that CPU is being busy, it displays that lag due to CPU usage. The game is running lag due to CPU usage. Ninth program explains why DMA is critical for large file transfers in industries like video editing and or banking. This generates 10 lakh values, represents huge file, and at last, using DMA, we copy all the data in one step. You can see large data transfer using DMA. The 10th program will explain DMA can help engineers design faster computer systems. Here generates 1,000 values, medium size real world data, transfers data instantly. DMA equals to fast plus efficient. So it shows high performance system using DMA. So this practicum successfully demonstrated the concept of direct memory access DMA using MATLAB. The simulation showed how data can be transferred directly between an I/O device and main memory without continuous involvement of the CPU. This was implemented by assigning data in a single step, representing high-speed block transfer. Different scenarios were explored, including a CPU-based transfer, DMA-based transfer, performance comparison, and real-time data handling. The results clearly showed that DMA reduces execution time, minimizes CPU workload, and improves overall system efficiency. Overall, this experiment provided a clear understanding of how DMA enhances system performance and why it is widely used in modern computing systems such as multimedia processing, gaming, and real-time applications. Thank you.